All right, so this is the Algebra Review Continued. I'm trying to make videos for all of them in case you struggle with them. Um, this is number 6. 9x squared minus 6x plus 1 is 0. Okay, this is one of those harder ones to factor, if it even factors, and I don't know if it does or not yet. We're going to have to see. Actually, I think it will. This one, if you notice, it's got this number in front of the x squared. So I could just try to guess and check and figure it out like this. But there's that other way that I really like that I think some of you might also benefit from. So I'm going to explain it that way in case you don't, if you have trouble guessing and checking. The other way to do it is to split the middle term and factor by grouping, which means I'm going to rewrite this equation here with 4 terms, and then I'm going to factor by grouping, okay? So what I'm going to do is this. I'm going to say I'm going to try to multiply the number out front, the 9, and the 1 that I've circled in red. 9 times 1 is 9. I'm going to try to find two numbers that multiply to give me 9, and at the same time they need to add to give me the number in the middle, negative 6. Well, that's not too hard to find, because if you think negative 3 times negative 3, that's positive 9, and if I add those two numbers, I get a negative 6. So I'm going to write my answer here when I get done. I don't know what it is yet, but I'm going to start doing this. I'm going to say I'm going to rewrite the equation. I'm going to, instead of putting minus 6x, I'm going to put minus 3x, because that adds up to negative 6x. I'm just rewriting it in terms of what I know I can do, okay? And then I got to put the plus 1 on the end. So what factoring by grouping is, again, is that you're going to group these two terms together, and then you're going to look at these two terms together. Now, this one's a little trickier than the one that was, here before. Let's just get started on it, and I'll show you where the tricky part comes in. If I look at 9x squared minus 3x, I'm just looking at those two terms. I'm looking for the GCF, the biggest thing that divides out of both of those terms, and I see that I can get a 3 out of both of them, and I can get an x out of them. So 9 divided by 3, if I want my leftovers out of that first term, would be 3. And I had an x squared, but I took an x out, so I have an x left. Then let me put a subtraction sign down. Now, I had 3x, but I took it all out. I have to put something there, because remember, I have to be able to get back what I started with, and if I don't put anything there, or if I put a 0 there, I'm never going to be able to get that minus 3x up on that equation back. So what I do is I look at it this way. I say 3x divided by 3x is 1. Okay, so I need 3x minus 1. I look over here, and there's not a GCF, and it looks really good, except that I've got the wrong signs on these numbers. So when you're factoring by grouping, one thing that you kind of have to do is anytime that between the two groups that you make, if you see a subtraction sign, you really need to factor that subtraction sign out. I'm actually going to do it in red. I'm factoring out a negative. I'm going to, or you remember, I can write a subtraction sign as plus negative 1, so I'm really going to divide out a negative 1 out of everything. So actually, let me put a 1 here, because that'll be helpful in a minute anyway if I do it. If I have a minus 3x and I divide it by minus 1, that would be a positive 3x. A negative divided by negative is a positive, right? So I can do that. And if I have a positive 1 and I divide it by a negative 1, I get a negative 1. One thing that factoring out this negative like I did does is it just switches the sign on both of the terms. I had a minus 3x up there in this blue right here, and now I have a plus 3x. I had a plus 1, and now I have a minus 1. And the reason I needed that is because if you look, now I have the same thing in both of those new terms that I created. So I'm going to factor that 3x minus 1 that's in both here and here. I'm going to factor it out. It's my new GCF. It's 3x minus 1. That's what was in both of them. So now I'm going to put my leftovers. If I look at this first term here, I had 3x times 3x minus 1, but I'm dividing that 3x minus 1 out, or I'm factoring it out. Factoring it out means I'm dividing it out. And so what am I going to have left there? I'll have left a 3x. Now I go on and I see there's a subtraction sign right there in the middle, that red subtraction sign right here. So I'm going to write it down. And there's if I look at what's over there, I have 1 times 3x minus 1. But if I take the 3x minus 1 out, I have a 1 left. So if you look at what we have here, we have 3x minus 1 times 3x minus 1. That's how I could factor it. Now that's not the answer because they told me to solve it. So to solve it, if you remember, it was already set equal to 0. And to solve now, what I have to do is take each factor and set it equal to 0. But do you notice that they're the same thing? Since they're the same thing, I don't have to write it down twice. I just need to write it down one time and solve it. So I'm going to set 3x minus 1 equal to 0. So I'm only going to have one answer here. I'm going to solve for x. I'm going to add 1 to both sides. I'm going to get 3x equal 1. And now to solve for x, I'll divide both sides by 3, and I'll get my answer, x equal 1/3. That's the solution. That's actually the answer we want. Okay, so I have this problem here, and I'm supposed to solve it, and that means I'm either going to factor it or use the quadratic formula. I'm going to go ahead. I notice that it's not set equal to 0. There are terms on both sides, so I'm going to move all the terms over. I'm going to choose the left side because I have a positive 3x squared over there, and I never want to try to factor with a negative x squared. So I'm going to subtract 12 from both sides, and that'll cancel that one out. And then to move the 5x over, I'm going to add 5x to each side, and that'll cancel that one out. And when they cancel out, they really add up to 0, don't they? So what I'll have on the left-hand side now is 3x squared. I'm going to put it in order, plus 5x minus 12. I don't know if this will factor or not, but if you remember, there's a quick, you could sit there and play with it all day long, but I'm going to go do that little factoring by grouping thing to see if it will. As what I did on the previous problem. It may not factor. I may have to go do the quadratic formula. If you don't want to sit there and figure out if it factors, you can go directly to the quadratic formula. There's nothing wrong with that. Well, if you remember, what I do is I multiply the term out front times the term on the end. 3 times negative 12 is negative 36. So I'm trying to find two numbers that multiply. I'm going to put mult up here so you remember. I'm trying to multiply to get 36, and at the same time, I want the terms to add up to be 5. So they need to add to 5. And if you think about it, 9 and 4 is 36. One of them needs to be negative. If I add that together, I get 13. But if I were to say 9 minus 4, I'd get 5. And that works. 9 times negative 4 is the negative 36. So I'm going to do this one factoring by grouping too, just in case if you know guess and check, fine. I just think this is a great way to do this if you struggle with guess and check. Okay, so I'm going to rewrite it. It's 3x squared. Instead of writing plus 5x, I'm going to write plus 9x minus 4x. I'm just splitting 5x. I'm rewriting 5x in terms of these two numbers that I found. And then it's minus 12 equals 0. All right, so if you remember what we do when we factor by grouping, we group it up into two sets of numbers. So I'm going to look at this first group here, and you take the GCF out. What divides out of 3x squared and 9x? Well, both of them can give me a 3, and both of them can give me an x. And my leftovers out of 3x squared would be x. Let me copy down my plus sign. If I had 9 and I divided out a 3, I'd have a 3 left. I had an x, but I took it out, so I don't have any x's left. Now I'm going to come down here and group these two together. All right, notice there's a subtraction sign there. Anytime you factor by grouping and you have a subtraction sign between your second and third term, between your two groups, you factor the negative out. You can look at it as dividing by negative 1, and that's really helpful. That's what I like to do. All right, so I also notice that both of those terms have a 4, so actually what I'm going to do is turn that negative 1 into a negative 4. I'm going to factor out a negative 4 because besides the negative sign, they also can both give me a 4. So if I take negative 4 out of negative 4x, I would have an x left. If I had a negative 12 and I divided a negative 4 out, a negative divided by a negative would be a positive 3. And now I have another GCF in each of these terms that I can take out, that x plus 3. So I'm going to take that x plus 3 out. It came from here and here. And I'm going to say, well, what are my leftovers? Well, if I look at my first term over here, if I take the x plus 3 out, I just have a 3x left. And now if I come over here and I look at my second set of terms, if I take the x plus 3 out, I have a minus 4 left. And I have factored now that problem without having to sit there and guess and check until I'm blue in the face. So now I've got to solve it, right? They didn't want me just to factor it. I factored it so I could solve it. And it is set equal to 0. I had to make sure that was going on before at the very beginning, if you remember. So to solve it, I take each factor, and I set them equal to 0. So I'm going to take x plus 3 and set it equal to 0, and 3x minus 4 equals 0. And if you remember, the reason I do that is if I'm multiplying these two parentheses together and I get a 0, it means one of the parentheses was equal to 0. So I set it equal to 0 to see what number I could plug in that would give me the 0. And those are my solutions. So on the first one, I would just need to subtract 3 from each side. A lot of times your answer is just the same number with the opposite sign of what was in the parentheses. Not always, though, because look at this one over here. In order to solve for x here, I have to add 4 to both sides. And I'm getting 3x equal 4. And if I divide both sides by 3 to solve for x, I get x equal 4/3, and that's my second solution. If we were working a geometry problem and we solved this, if we're just doing algebra, these are both the solutions. But in geometry, a lot of times what happens is when you're solving, you get a negative number, and you can't, you don't have a negative distance or a negative length of a figure. So a lot of times we throw out the negative one in geometry, but we never throw it out in algebra.